arc flash study is that requirement from 70E to choose the appropriate PP. We need a calculation as to how much energy could be released. And that ties really back into another standard that's IEEE 1584. Most of us are familiar with the 2002 version of 1584, which was really the first standard where we had good test data. And when they wrote that standard, they tested equipment, they actually blew it up in labs and measured how much energy is released during an arc flash. And from those measurements, they were able to build the equations to calculate how much energy would be released, in theory, in any piece of equipment. And that takes into account what size the equipment is from an ampacity standpoint, but also what's the voltage of the equipment. How big is the box? Are we talking a switchboard, or are we talking a panel board? Grounded, ungrounded. A lot of very significant details go into that arc flash analysis. It was just revised here a few years ago, so we have the 2018 version of 1584. What's important with that revision is they actually looked at the bus orientation. So is your bus bar in the equipment running vertical or is it running horizontal? They found that that actually makes an effect on the calculation itself. So an arc flash study takes all those equations and all that test data into account, and in essence, we model your system in software, and that software will do the calculations for us to tell us how much energy is going to be released. It gets very technical in those equations, so I don't recommend diving into them and trying to do them by hand, but also it gets technical from the perspective of what's your system currently running in state-wise? Are you running on utility power? Are you running on generator power? Do you have motors turned on right now that can regenerate current back into the fault, or are they all turned off? Those all will affect that analysis, and ultimately the software and the engineer doing that study in the background takes all that into account to determine what's the worst case energy that could be released. Typically in an arc flash study, it coincides with a short circuit analysis and a coordination study. So short circuit would be how much fault current can be released in your system. And that's based off of the equipment you have and how much impedance or resistance the system has, but it's also based off of how strong your utility is. We're outside of Pittsburgh, Pennsylvania right now, so our services here are pretty powerful. We can get a lot of fault current from the utility. If your facility's out in the middle of the country, far away from major cities, you're not going to nearly have that high level of fault current that you have if you're in the city. So fault current comes into effect. The short circuit analysis will confirm that your equipment can actually interrupt that fault. It's not the 25 amp or 50 amp breaker. That's not the rating we're looking at. We're looking at the 10,000 amps interrupting rating on the breaker or on the device. So that's a short circuit analysis. It's ultimately required in an arc flash study to determine what all the fault values are going to be. Beyond that, you have the coordination study. The coordination study is all the settings for your breakers, all the sizes of your fuses and other protective device relays in your system. And what we're looking for is to ensure that your downstream device that's closest to the fault will interrupt that fault first. So if you think about it in a residential setting, if I create a fault in an outlet in my living room, I only want my living room to go out. I don't want my main breaker for the house to trip, or I don't want the utility fuse on the pole to end up blowing. I only want that small 20 amp receptacle circuit to trip offline. That's what a coordination study does. It ensures that your closest downstream device trips first. And why that's important into an arc flash study is when I take the fault values from the short circuit and I take the timing from the coordination study, those are two primary factors that go into the arc flash analysis. So typically you'll see an arc flash study combined with a short circuit coordination from that perspective. When we look at the time frame for an analysis, coordination and short circuit studies are required anytime the system changes that's going to affect those results. You want to make sure you go back and have those updated. An arc flash study in 70E specifically has to be reviewed every 5 years minimum. So every 5 years, you should be having an engineer look at that system, look at the analysis to ensure it was still an accurate calculation. If nothing changed in your facility, it might be as simple as let's talk to the utility and make sure the fault current values haven't changed, and just have a site visit to ensure that, yeah, it's still a valid calculation. But anytime you have the utility making changes, you make changes inside your system, 70E is going to require your arc flash study to be updated, but it is a 5-year maximum review of that study. If you have a hospital, hospitals are going to have requirements for selective coordination, which is in essence perfect coordination. So you have to have the coordination study that does that as well as the arc flash analysis. But then also in your commercial industrial facilities, you still have life safety systems, right? We have emergency lighting systems, we have fire pump systems in play, and those are also required to be selectively coordinated to some level. So yes, we have to have the coordination study and the arc flash study both from a perspective of code and standards. It's twofold. Number one, it's from just the facility itself and keeping it operational. I mean, depending on the facility you have, if you have a miscoordination occur and a fault takes down your operations, that could be significant money loss for your facility if that happens. If you have equipment where we actually have a failure and we actually damage equipment in that fault, lead times for equipment can be weeks, months, years at this point. So, that downtime is a huge cost. Second that to safety. If we don't do the analysis and make sure our system is going to stay up and operational in a safe manner, we're putting all of our employees at risk. Your actual electricians that are maybe going into the equipment and making changes to it, but also just anybody that's exposed to electrical equipment. A lot of facilities, the electrical rooms are not necessarily separate rooms. They're rooms that other people have access to. Painters, plumbers, just carpenters, etc. Maybe office personnel walk by panel boards that are out in the hallways. If that equipment's not properly maintained, if we haven't done the proper analysis to ensure it's going to stay working and that we're protecting our employees, that puts everybody at risk. Number one, we're a little different because we're a manufacturer of equipment. So when we talk about bus orientation of the equipment or what the ratings are of breakers, of fuses, we manufacture those devices. We are part of testing of those devices when they're being manufactured, going the whole way back to getting UL certification and understanding all those tests that device had to go through. Also, we've been in the industry for a good number of years now. Our engineers doing arc flash studies, our trainers that are doing training, as well as our field employees that are working out on sites every day, they've been in industry. We have a large number of average years in each one of those groups of experience. Make sure you reach out to your ErieTec representative. They can sit down with you, really hone in on what your needs are, what you need for your facility and for your employees, and then they can work with us at Eaton to make sure we can provide those services.